In the last video, we discussed about linear regression. Now, let us see linear regression in action, and we will use Excel because it is easy to understand through Excel. Now, Excel is useful for conducting linear regression when the data set is small. Also, it is good for linear regression, though it is not so good for other forms of regression. So, we will use Excel basically to understand the concept of linear regression before we move on to Python programming, where we will see how actually it is done. So, let's go to Excel. So here we are in Excel. So what we will try to do first is that we want to find this variable scaled sound pressure level for a given value of frequency. Now we have observations here which we have made for different frequencies. What is the scaled sound pressure level? So let's see how many observations we have. So if I say count, and if I take this whole stuff, count and this, so we have 1503 observations. So now from these observations we would like to figure out whether we can determine the value of scaled sound pressure level for a given value of frequency. So now we will do linear regression. So we know that we have to find first the slope and the intercept. So we have to find the slope and the intercept. So let us try to find that. In Excel, it is quite straightforward. So there is a function called slope. So you can say slope. Then you need to give the known y's. The y's are here. That is a variable which we want to determine. And then followed by the x's. The x's are the frequencies. So based on the value of frequency, we want to find the value of scaled sound pressure level. So once we do that, we get the slope. Then we can find the intercept. For intercept, we can use a function called intercept. So this is very straightforward. So we can say intercept. Again, we need to give this known y's followed by the known x's. So once we do that, we get the value of the slope and the intercept. Now once we have got the slope and the intercept, we can use these values to predict the value of y. So here, this is our y. So this is y, and this in this case is our x. So I can just adjust the column width. So there we have it. Now I want to predict the value of y. So I will say this is the predicted y. So predicted y I should get here. Now I can do the prediction by using my slope and the intercept. So the formula is going to be, this is equal to the intercept plus the slope into the x variable. So this is the formula. I will just anchor this because these values will not change. So once I do this, I have my formula for the predicted y. So I can just copy this. So I can go right up to the bottom and I can copy this. So there I have all my predicted values for the given x's. Now you notice that the predicted value is different from the actual value. So we had seen that the line of linear regression that will not be able to always produce the exact value. So there will be some element of error. So this element of error, we will see how to treat this in the next video when we discuss about errors and how to see the goodness of our model. Now you notice that we are able to make a simple linear regression equation for two variables. There is a much simpler way to do this in Excel. What we can do is that we can take advantage of the data analysis toolkit. So if I go to data analysis toolkit, here you notice that there is a option for regression. If I use this option and it will ask me for certain things, it will ask me what is my input y range. So I know my input y range is this one. So I can give my input y range as the variable which is my output variable. And it will ask me for the input x range. The input x range is here. We will just go to here. The frequencies are my input x range. So I say that these are my input x range. I will say that I've included labels because you notice that I included the labels. Then I can say output this in this sheet itself. So I can say that the output needs to be provided here itself, and I can tell him to give me the residuals, the standard residuals, the residual plots, and line fit plots, and normal probability. I'll show you all the items what it can provide, and then we will later on discuss what this all means. So now if I say okay, it will produce the output for me. So you notice that it has given me the intercept and the slope first. So notice that the intercept is the same as what we calculated and the slope is the same as what we had calculated. So this is the first output which is important for us. And then based on this intercept and slope, it has produced the predictions. These predictions is the same as what we had produced from our calculations as well. And the difference between the predicted value and the actual value is known as the residual. So this residual also has been calculated. So this is a much simpler way, and this way will be required when we are going to do regression with multiple variables. So now let's move to the next topic where we will try to see how to do regression with multiple variables. So here we have in this sheet the different variables which impact the scaled sound pressure level. So we have 5 variables: frequency, attack angle, chord length, free stream velocity, and thickness. So based on these 5 different variables, we would like to predict the value of scaled sound pressure level. So now, instead of trying to do manually, let us use the data analysis toolkit. So I will straight away go there and I will say regression. I will choose this. Then it will ask me what is your Y range. So my Y range, I will give it as the Y range is here. That is, this is my Y. And my X, this time it contains more than just one variable. So this is all of these variables put together is my X range. So I give that. I say labels have been included and my output is going to be produced here. So I say produce output here and I ask for all the different outputs. So if I say okay now, it should calculate the different values for me. So there it has done it. So notice that we have got an intercept now and we have got the slopes for each of the different variables. So my equation becomes, this is beta 0, that is 132.83, that is beta 0. This is beta 1, that is minus 0.00122822 into frequency, plus minus 0.421947 into attack angle, plus minus 35.688 into chord length, plus 0.09985 into free stream velocity, plus minus 147.30052 into thickness. So if I use this equation for any given values of these 5 variables, I should be able to get the value of the scaled sound pressure level. So that is how we have done the linear regression. So now next we will try to understand how good is our model by looking at the statistics what is produced. So what the statistics means, we will understand that in the next video and then proceed with our further discussions.